Good afternoon, everybody, and a warm welcome to our WRE Environmental Destination Insights webinar. I'm delighted to have you with us this afternoon and to have a deep dive into environmental destination as we go through the next hour. We've put this together for you as an insight into environmental destination and to lead into some of the engagement that we're doing through the winter. And I think you'll find the next hour fascinating, hopefully with lots of opportunity for discussion as we get to the end. So I'm Teresa Meadows. I work as a stakeholder lead with the Water Resources East team, based covering the east of England, and one of my key focuses is environmental destination and working with you all across the region to understand the ambition for our environmental destination and to realise how that will work for yourselves as businesses, for us as individuals, communities, and our environment. So just to start with some housekeeping for today, this is a webinar, so sadly we can't see you or hear you today, but you can very much stay in touch with us. There's two ways of doing that. One is to use the chat, and we've also got a question and answer function as part of today as well. So if you'd like to use the chat for kind of anything to share with us in terms of technical issues, but if you'd like to ask a question to one of the speakers, if you could pop that in the Q&A, that would be brilliant. The session is being recorded and the slides and the recording will be shared after the meeting today. For those of you in the agricultural industry, if you're a BASIS or Neroso member, we've registered the session today for professional development, and it'd be great if you could pop your membership number in the chat and I'll organise that at our end. So the agenda for today, I'm delighted to welcome our speakers to provide you with the technical insights as we go through this afternoon. The first session is going to be a dive into environmental destination from a technical aspect, how environmental destination is made up, and how that is reflected in terms of water resources, both from a surface water and a groundwater point of view. So Tom Reed is a hydrogeologist working with Anglian Water that has got a real interest and expertise in groundwater flow and the effects of climate change and abstractions working in that area. So welcome Tom, and Tom will take us through that first bit. And then pleased to welcome Andy Davey, who's an Associate Director at APEM, that's going to really talk us through hydroecology, and so how that ecological links back to our water environment and what we can learn from that relationship for environmental destination. Andy's got a background in interest in using evidence for insights in terms of our environmental risk and improvements in terms of statistical modelling, analysis and direction. And so pleased to welcome Andy, who's going to take us through that today. And then this all comes together for you across the region and down within our catchments in terms of water resource planning on our level and yourselves as kind of business and sector kind of plans. And I'm pleased to welcome Joe Ledger, who's here on behalf of Water Resources East and Anglian Water, that's really put a lot of work into the thinking behind how we can link catchment decision making and the work on the ground with how that works across the region. Joe has a role that links water resource management planning and the drainage and wastewater management planning for Anglian Water, and very much kind of feeds in to the meeting. So that's the plan. We'll go through those, and then we've got an opportunity for questions and answers as we go through later, and I will finish with next steps for 1 o'clock. So really environmental destination, and Tom's going to talk through the details of what that is, but that really takes us through regulated by the Environment Agency, looking at what that future and ambition is in terms of our water environment and how we can get there and achieve that. And today really is about bringing that technical understanding of what that means in terms of our hydrological environment and putting that together with us as businesses, how we use that water and how we can make sure that we meet between that. But we're just before we start, and Al, if you'd like to launch the poll for us, we'd like just to kind of do an understanding for you of what's your current level of understanding of environmental destination. So hopefully on your screen, a poll should have popped up. And you should be able to select your current understanding and press that through, and then we should be able to see what people's kind of thinking about in our area. So great, well done. Thank you, those of you that are interested and been able to do. That's most of you. It's 3/4 now have answered that poll, and a large part of you have got some understanding. Got some experts in the room, and some people that are hearing about environmental destination for the first time. So welcome to all of you. Hopefully by the end of the session you'll have learned a lot more about that and we'll be able to take that forward. So without further ado, I'm going to hand over now to Tom Reed, and Tom is going to talk us through environmental destination and how that's calculated. Over to you, Tom.
Well, yeah, thanks, Teresa. Oh, just seeing the poll appear. I don't know if the slides have disappeared.
You start. I'll bring it up.
Well, okay, yeah, thanks, Teresa. Looks like it's loading. Excellent. Well, is that skipping on now as I move through?
I think you might need to take control again, Tom.
Ah, okay. Looks like, yeah. Excellent. Well, okay. Is that on the environmental destination slide now?
Yeah.
Excellent. Okay, we're there now. Perfect. Bro, so yeah, environmental destination, what is it and where did it come from? So environmental destination, planning for water resources, first entered into the UK water management framework in 2020 with the publication of the National Framework for Water Resources. The national framework set out a strategic regional approach which considered environmental outcomes alongside public water supply, agriculture and industrial water needs. And it effectively introduced environmental destination as a method to identify where abstraction needs to change, plan for long-term sustainable water use to achieve and maintain ecological health of rivers, wetlands and groundwater, and thirdly, incorporate climate change and water demand growth into water resources planning. And I think these points are quite neatly summarised in the definition above, which comes from the revised national framework, which was published in July of this year, which builds on the original national framework with some enhanced scope and updated future projections. But how is this kind of different to what's gone before in terms of previous abstraction reform? So just to take a brief look back, the first recognisable bit of legislation we had around abstractions was the Water Resources Act of 1963. And this required most water users to obtain a licence, but the focus was very much on resolving conflicts between neighbours rather than managing environmental impacts. In the last 30 years or so, we've gone through a period where the environment has been increasingly recognised through, firstly, the Water Resources Act of 1991, Water Act in 2003, the Restoring Sustainable Abstractions Programme, and then the establishment of river basin management plans driven by the Water Framework Directive. And we've also got some strategic government action plans such as the chalk stream strategy and the salmon 5-point action plan. So there's been lots of things brought in, lots of different drivers, legislation and strategies that have evolved. But the idea is that environmental destination pulls all of this together to give a coherent long-term view on how we get to where we want to be in terms of having sustainable abstractions. But how exactly do we go about assessing this? So in order to look at the sustainability of an abstraction, we need to have a reference point and determine what the flows should be there, firstly, in the absence of an abstraction impact. So just to give an example, we've got the Lark catchment on the left-hand side in the WRE region, and we've got a reference point on the Lark catchment, which is the star on the map, which refers to an Environment Agency river gauging station. And then on the right, we've got some daily river flow data that was taken here. One of the key ways to summarise and represent the behaviour of flows, potentially from a data set such as this, which could be spanning many years, is through the creation of a flow duration curve. And this is a graph which shows the probability of exceeding a given flow. And this is generated by ranking the flows, in this case, the daily gauge flow from high to low. And depending on how frequently these flows are being measured and the total length of the record, each of these flows are assigned a percentage sort of probability of exceedance. So, for example, just move on here. If you had a record that had 100 daily flows, your highest flow from that record would plot at the first percentile as shown there. And you effectively go through that record to build up this flow duration curve. So as you go along the curve from the left to the right, effectively you're saying that at a given position, there's a certain percentage probability of flows exceeding this value. So on this curve, our midpoint 50th percentile is effectively the median flow. And if we go along it a bit further to our 95th percentile, which is a commonly sort of referred to point, that's representative of a low flow on that river. But this flow duration curve that we've created here is made up of observational data, which in this case and in general will be already being affected by abstractions. So, but we really want to know what the curve would look like in the absence of any abstractions in order to provide a kind of adequate baseline reference. And this kind of reference flow duration curve would be called a naturalized flow duration curve. And we typically have to rely on numerical modeling to produce this because it's a situation that hasn't existed for kind of decades and centuries. And we simply don't have the observational data to construct this. So yeah, how do we get to that? So in the Eastern region, water resources planning is underpinned by 5 large-scale regional groundwater models. These were initially created in the early 2000s and have been continuously developed since then. And these groundwater models incorporate the geology of the region and they explicitly include all licensed groundwater and surface water abstractions as well. So these models allow river flows to be predicted at any specified location according to an input of climate data and an abstraction scenario. So the models could be run with none of the abstractions operating, and this then effectively produces an artificial river flow time series or hydrograph from which we can construct our naturalized flow duration curve, which is what's shown in the black line there. So the environmental flow indicator approach is what we use to assess sustainability, and this effectively says that there's a minimum flow, a range of percentiles that is acceptable for the ecology that's being supported by the river, and that's referred to as the EFI or FE. And effectively, the size of that gap between the naturalized flow and the FE is essentially representative of the amount of water that's available to be taken out and be used by abstractors. But where exactly do we set the line that the FE is being plotted at? So for this, we have some abstraction sensitivity bands to refer to, and these have been around for a little while, but they remain a key part of water resources assessment for environmental destination. So for some chosen key flows, so we've got the 30th, 50th, 70th, and 95th percentile. The ASB classification states an acceptable level of deviation from the naturalized flow. So yeah, you'll notice that there's 3 ASBs here, and that's to allow for a greater amount of abstraction in less sensitive rivers, and less abstraction in rivers with high sensitivity. So for instance, chalk streams that we might want to protect more. So for example, for an ASB1 water body, you'd be allowed to remove 20% or allow a 20% deviation from naturalized flow at Q95. And that's shown in the bottom right corner of that plot there. So we've now got our target flows that we need to meet, but how do you then assess the impact of an abstraction to see if enough water is being left in for the environment? So for a surface water abstraction, that's relatively straightforward. You know exactly where the impact will be. So that's the location at where the water is abstracted and taken out, and the entire reach downstream of this. And you also know when that impact is going to be felt, because the river is almost instantaneously responsive to pumping. So for an abstraction that operates continuously, all flow percentiles will be equally affected, and you'd effectively just be shifting the flow duration curve down by the licensed abstraction rate, which is what's shown by the blue dashed line there. But for a groundwater abstraction, where is the impact felt in the surface water receptor, and when is it felt? It's a bit more complex than that. So this sequence of schematics aims to demonstrate some of the complexities around defining the spatial impact of groundwater abstractions. So here we've got a little valley with a stream at the bottom. And if you go beneath the surface, we've got our water table and groundwater. We've got a gradient on the water table as shown by the white groundwater level contours, which result in a flow of groundwater towards the stream, which is being shown by the green flow lines. So yeah, groundwater discharges to the stream, and as the stream flows from left to right, it gains in flow. This gaining flow distance along the river is shown above in the flow accretion curve. So if we then put a groundwater abstraction in the environment, pumping causes groundwater levels in the vicinity of the borehole to decrease, and a cone of depression forms. And we get flow towards the well, as shown by these yellow flow lines. And in this case, the water for the abstraction comes from groundwater at the expense of groundwater being discharged to the river. So on our flow accretion curve, you can essentially see the yellow line flattens out in the vicinity of the borehole. If we then pump a bit harder, we get an even bigger drawdown, a bigger cone of depression. And in this example, we've actually reversed the hydraulic gradient in groundwater, and we're now drawing some of the river water itself into the borehole. And you can see that the length of river that's being impacted is also now much greater, and I'll just put a red dot on the accretion curve to show the point at which the flow and the river begins to kind of gain at the same rate again. So for a groundwater abstraction, where it's located in relation to the point of assessment really makes a difference in terms of the level of flow modification or deficit you'd expect to see. And it also means that for certain pairings of abstractions and assessment points, you need to make a large reduction in abstraction to get a small amount of flow recovery. So those kind of complex spatial impacts associated with groundwater abstractions are pulled out of the regional groundwater models held by the Environment Agency and are assigned to individual abstractions. That information is fed into the EA's Water Resources GIS and CAMS ledgers for assessments of water resource availability. So for ED, National Framework 2, that same data on the spatial and temporal impacts of abstractions is used to calculate both the scale of the flow deficit and then to inform how abstraction reductions need to be made as part of the solution using an optimization tool. So following this example through, if you were to combine the impact of multiple groundwater abstractions and perhaps some surface water abstractions, you'd end up with the fully licensed flow duration curve showing the blue dashed line there. And you can see that somewhere around the 70th percentile in this example, the flow drops below the FE and then it remains non-compliant up to beyond the 95th percentile. So in this case, yeah, that's an example of an unsustainable set of abstractions. So what about climate change? So climate change is explored through some scenarios at a near and distant future in ED. This is the 2050 and 2080 outlook. So these figures are from the EA's July this year ED guidance that was published, and the colours represent the median percentage change in predicted Q95 low flows from 12 regional climate models. You can see that only in parts of northern England and parts of Scotland is that they're expected to be kind of a negligible change or even an increase in Q95. The picture sort of particularly in the WRE region is very pink and red. So we've got reductions in Q95 low flows. So it's not a good outlook for the environment in terms of the extra stress that this will put on the ecology, and yeah, it's clearly not a good outlook for the future of water abstractions. So just very briefly, because I'm sort of rapidly running out of time, but just specifically in the WRE region, these histograms summarise the percentage reductions that we're expecting to see in those different scenarios for two different climates, a wetter and a drier climate. I've put on there a dashed yellow line to show the 0% change point, and effectively everything is plotting to the left of that. So that's, you know, some fairly hefty reductions in naturalised Q95 low flows. So yeah, what does this mean in terms of what we can abstract from the environment in the future? So for this, we go back to our flow duration curve, remembering that the amount of water that's available for us to abstract is essentially this kind of gap between the flow duration curve, a black line, and the FE. So in a future climate, the flow duration curve may look something like the black dashed line, and the FE is hung beneath that by the same percentage amount if we assume the same level of protection in the future. So the key thing to be aware of here is that we're not holding the line in terms of climate change. Future naturalised flows are going down, and so does the future FE. But this does mean that the size of the allowable abstraction impact, which is that gap between the naturalised flow and the FE, is effectively, that's being squeezed by climate change and gets smaller. So that's what's driving the abstraction reductions that go on top of meeting the kind of obligations now in those future scenarios. And yeah, that's kind of what's then driving these kind of outputs and the percentage ranges of future reductions. So yeah, thanks for listening. Hopefully that was a useful run through of some aspects of abstraction sustainability and ED. Feel free to pop any questions in the Q&A function, or yeah, reach out outside of the call. Thanks.
Thanks very much, Tom. There's a lot covered there, and a very brilliant description of how that comes together in terms of both of our surface water and our groundwater, thinking about climate change in the future. Yeah, thank you. A round of applause there for Tom in a virtual way. So well done, Tom, because there's a lot to kind of take away and describe. There we go. Thank you, everybody. How brilliant. I feel like we're in a conference theatre and engagement. Yeah, thank you, Tom. You don't often get that in there. So thank you, everybody. I'm sure there's lots of questions, but I think it's really valuable to have that opportunity to think about what the data is behind there. So we'll come back to kind of questions in a minute as we go forward, but we're going to hand over now to Andy, and Andy's then going to take us through how that all links to the ecology in there. If Andy's disappeared from my screen, hopefully you're there, Andy, and to be able to take us through what this then means for our ecology, how we can use the evidence to take that forward. So over to you, Andy.
Thank you, Teresa. Can you still see the slides? I've moved on to the
that's perfect.
Presentation. Great. Good afternoon, everyone. My name's Andy Davey, and as Teresa said, I'm a freshwater ecologist, and I work at a company called APEM, who are one of the largest aquatic science consultancies in the country. I'm a self-confessed data geek. My research interests focus on trying to use environmental monitoring data to better understand how abstraction, water quality and habitat influences combine to influence the status of our rivers and lakes. And in this short presentation, I wanted to give you a little bit of a heads up about some innovative research that Water Resources East are undertaking to try to better understand how our rivers tick, how abstraction influences them, and how we can manage our abstractions more sustainably going forwards. Now, environmental destination is a really interesting way of looking at that challenge of managing rivers, and it raises lots of new questions which we haven't really had to tackle really at this sort of scale before, because environmental destination forces us to think longer term, to factor in the effects of climate change, and also to take decisions about abstraction at a much more regional scale. So some of the questions which commonly crop up when I talk to people about abstraction and its effects on rivers are: what is the effect of those abstractions? Which watercourses are most sensitive to changes in flow? And also, where we do see ecological impacts, what is the relative contribution of abstraction versus other pressures such as water quality? Environmental destination, as Tom was just saying, forces us to think about how growing demand for water and climate change might pose additional risks to the ecology of our rivers. So we need to start answering questions such as: how will the ecology respond to predicted changes in flow under different climate change scenarios? And also, if we were to manage the way in which we abstract and use water, what would be the effects of that if we were to operate our assets differently, or even move water between catchments to try and balance where water availability against water demand? And fundamentally, environmental destination challenges us to come up with both short-term and long-term actions for trying to manage those abstractions more sustainably. And fundamental to that is trying to understand how much water do rivers need to achieve their environmental objectives under the Water Framework and Habitats directives. And if we are looking to reduce abstraction going forwards, to make licence reductions, where will that deliver the greatest benefit? And to look at things in a broader perspective, we've also got the potential to take other steps to try and tackle pollution, or to restore the habitat within the river, to try and improve the resiliency of the ecology to both low flows and climate change. So thinking, if you like, beyond just reducing abstractions, trying to look at a larger package of measures that can help to make our rivers healthier and stop them deteriorating in the future. So really, I think if you boil all of those questions down, we can look at this in three ways. We first of all need to look back, understand what is causing the impacts in the past and today. If we can understand what's making the ecology tick, then we can use that information to try and predict what's going to happen in the future. And with a good understanding about where those future risks are, we can then make more informed decisions about where we invest money to try and protect and restore those river ecosystems. So to provide answers to those questions, we need a way of integrating all of the evidence, all of the monitoring data that we have available to piece together a complete understanding of how abstraction influences groundwater levels and river flows, how that interacts with other pressures such as water quality and habitat, and how that ultimately influences the condition and the status of our ecological communities. Now, as Tom was saying in his presentation, we're quite fortunate in the UK to have a wealth of models which tell us about different parts of the system. We have a lot of hydrological models which give us that good understanding about how abstraction influences river flow. We also have water quality models and habitat models which tell us something about how organisms respond to the physical and chemical conditions in the river. But for many years, we've had a long-standing gap, which is trying to translate those physical and chemical conditions into a prediction of how healthy the biology is. And when we're talking about biology, we're thinking about invertebrates, fish and plants, which make up the river ecosystem. So the work that we've been doing at APEM now for a number of years is to try and develop a new breed of models, which we call hydroecological models, which try to bridge that gap between changes in flow, changes in chemistry and habitat, and use that to give us a much better understanding of what the ecology is going to look like both today and in the future. So what is this approach that we call hydroecological modelling? Well, essentially, it's a statistical regression modelling approach, which allows us to bring together measurements of the ecology. So that could be a fish survey or an invertebrate survey or plant survey, and then to try and explain the variation in that ecological community in terms of the flow conditions that those organisms have experienced. One way of doing that is to take ecological sample data that's been collected over many years and to contrast those data under wetter and drier conditions. That's a useful way of contrasting how organisms respond to both floods and droughts, and that can tell us quite a bit about the sensitivity of those organisms to changes in flow. And that's a very useful approach if we've got a long time series of monitoring data. But where we lack that, an alternative approach is to collect monitoring data from many different monitoring locations across different river catchments, and to use that to compare the ecology under more or less natural flow conditions. So, for example, we can compare what an invertebrate community looks like in a catchment which is heavily influenced by abstraction and compare it to other control catchments which have little or no abstraction pressure. And one of the beauties of this approach is that by bringing together lots of data from many different similar monitoring locations, that gives us much greater insights into how the ecology responds to flow than we could possibly get by looking at individual problems in isolation, one site at a time. Now, being a statistical approach, we can also take into account other confounding factors. We know that most of our river catchments aren't influenced by just one pressure alone. They're often subject to many different human influences. And so if we can characterise the effect of water quality or signal crayfish or fine sediment pressure, we can incorporate that into these models as well. So although hydroecology modelling focuses on trying to understand the effects of flow and abstraction on the ecology, we can also use it as a broader modelling framework to try and understand the relative influence of those pressures and even how they interact with each other. So the goal is to basically bring together the wealth of historical monitoring data, put that into a statistical model, calibrate the relationships, and then use that calibrated model as part of a wider weight of evidence approach to try and manage abstractions more sustainably. And on this slide, I've just listed out at least 3 different applications that I see for these models in the context of environmental destination. The first is to use those calibrated relationships, that is the sort of the shape of the curve between ecology and flow to try and define more locally tailored environmental flow targets. Tom gave us a very useful introduction to the environmental flow indicator, or the EFI, which is, if you like, the default method that we use to understand how much water a river needs to achieve its ecological targets. But the EFI is a starting point. It's a national scale screening tool. And whilst it does allow some variation in flow targets to reflect high, medium and low sensitivity to abstraction pressure, what it doesn't do is incorporate any local evidence about that link between ecology and flow. So we see potential to use hydroecology models to help give us a more locally tailored assessment of environmental flow needs. And the Environment Agency last year published some new guidance called the Local Flow Constraints Guidance, which advocates this approach to try and come up with a better evidenced assessment of where and when we need to reduce abstraction. The second application is to use these models to forecast what's going to happen in the future. We know that climate change is going to drastically reduce flows in most river catchments, as Tom showed on his earlier map. And we also know that there's rising demand for water from both a public and water supply and non-public water supply abstractors. If we can forecast how climate change is going and demand is going to change river flows, then we can feed those assessments of flow change through the hydroecology model and translate that into an assessment of how fish and invertebrate and macrophyte communities will change as well. And that gives us a much better understanding about what threat is posed in the future, what degree of change we might see, and where action is needed most. And the third application is then to try and inform decisions about what actions we need to take. So, for example, if an abstractor is considering reducing abstraction, making a license reduction, we can use hydrological models to predict the degree of flow recovery. And again, we can take that a step further using the hydroecology model and predict where, how much and how quickly the ecology might respond to that increase in flow. If we're also considering other complementary catchment-based options to reduce agricultural diffuse pollution or maybe localized habitat restoration projects, we can potentially use these models as well to give a prediction about how much those other supporting measures might improve the ecology. And using this evidence, we can then both optimize and prioritize where we want to take action in the shorter and longer term. It's really important that because we can't solve every problem everywhere, we need to be very targeted in where we spend money. And these kinds of models can help us to give us essentially the biggest bang for the buck, make sure that we've got clear evidence that where we do invest money, we will see a tangible ecological benefit as a result. Now, the approach we are taking for water resources east is still very much at its early stages, but we have experience at APEM of undertaking these kinds of studies for other water companies. And the example on the slide here is some work that we've undertaken for Severn Trent Water to understand the effect of their groundwater abstractions in the Midlands. The relationship you can see on the screen there shows how, as abstraction pressure increases from left to right, the status of the invertebrate communities in those rivers starts to diminish. And you can see there's a sort of clear turning point halfway along that curve, at which point abstraction starts to have a more severe impact on the health of the invertebrates. Having calibrated that relationship, we were then able to help Severn Trent make decisions about where reductions in groundwater abstraction are most needed and where that would deliver the greatest ecological benefit. The two maps you can see there explore two different license reduction scenarios, and the coloured lines indicate how much we expect the invertebrate community to improve as a result of reducing abstraction. And what's really interesting is that you get different degrees of benefit depending on where you make those cuts in abstraction. It depends partly on the size of a watercourse and also on the degree of abstraction pressure that we experience today. So using this evidence-based approach, Severn Trent was able to agree a package of licence reductions with the Environment Agency, which maximised the expected environmental benefits. So turning the attention to the east of England, we have been working alongside our partners at WSP for Water Resources East through the course of this year to start looking at how we can apply this hydroecology modelling approach to the WRE region. Specifically, we've been reviewing the wealth of invertebrate and macrophyte monitoring data that the Environment Agency have collected over the last 25 years and mapping that out to see where we've got a good amount of data and how we can use that to calibrate a hydroecology model. On the map there, you can see 5 different coloured areas which represent the 5 different regional groundwater models available in the east of England. And those give us a really good handle on how abstraction is affecting groundwater levels and flows. And within those areas, we've identified monitoring points which have got sufficient data to tell us something about that link between the ecology and flow. We've also done some preliminary work to see how we can really try to characterize water quality and morphology pressures within those catchments as well. And we've also developed a typology system because we know that not all rivers respond to abstraction in the same way, and we want to try to group together similar monitoring points. And after taking into account a wide range of factors, we've broken that monitoring data down into 2 groups for chalk and non-chalk rivers. So on the map, the white points represent the chalk rivers overlying the blue watercourses, and the black monitoring points are the other monitoring locations off the chalk. We expect those 2 different types of river systems to vary in their sensitivity to abstraction. And through this exercise, we've identified a sufficient amount of monitoring data, which we are hopeful can give us insights into those hydroecology relationships. That was stage 1 of the project, and we are currently agreeing the scope of work for a follow-on stage of work, which is going to run through the autumn and winter and look to complete by March 2026. That stage 2 is going to take the data that we've accumulated in stage 1, run the groundwater models to understand exactly how abstraction is altering flows at each of those monitoring locations. We will then do some additional work to understand the degree of water pollution and channel modification at those locations and plug all of that information into a hydroecology model. We're going to focus on invertebrates initially because there's a lot more data available for invertebrates than macrophytes. And we also know from previous work that invertebrates represent a particularly sensitive quality element. They provide a good indicator of how the ecology generally is in fact influenced by abstraction. And so by the spring, we hope to have some initial prototype hydroecology models for the east of England, which can be then used to better understand and target interventions as part of the next regional water resources management plan. And looking a little bit further ahead, we also want to try and identify where future monitoring can be best targeted to help improve the calibration of these models as well. We are blessed with a lot of monitoring data, but strategically planning that monitoring to make sure we're covering a wide range of conditions and a wide spectrum of anthropogenic pressures is particularly beneficial for this kind of modelling approach. That's really, I think, as much as we've got time for today, but happy to take some questions towards the end of the webinar if there's time available.
That's fantastic. Thank you, Andy. A very clear run through of why hydroecology is important and how we can use modelling and approaches and the understanding that we've got to support how that moves forward. So thank you very much, and thank you to you all for putting your questions in the chat as we go through, and we'll ask those to Tom, to Andy and to Joe in a minute. So I'm now going to hand over to Joe, and Joe is just going to take us through some of the catchment decision making and how you can get involved in the future, what this looks like.
Thank you, Teresa. Sorry, I'm just trying to find the slides again. Can you see them as they come through? I'll just get to my bit. But yeah, as Teresa said, I'm I'm just going to talk through kind of how we intend to take all this information and then feed it through into sort of decision making and development of our various plans. So for this sort of round of developing the regional plan and the other sort of water company plans, we've introduced a new sort of level of decision making at catchment level. So this will be at operational catchment level. So I believe within the Anglian region, we've got about 66, 70 operational catchments. And the idea is at this scale, we can then consider all of the impacts in that catchment. So we can look at environmental destination, but also water quality, flood risk, and sort of morphology issues. And with this sort of smaller scale decision making, we'll then be able to inform our water resource management plans, our drainage and water recycling plans, but also other sector plans that kind of all feed in and interact at that scale. And then using this sort of wealth of knowledge and decision making, we can form this all together to create the regional plan and take forward to the regional decision making. So how we set out this approach to do this catchment scale decision making is through a series of workshops with sort of all stakeholders and parties involved and interested within that particular operational catchment. And the idea is we start this by bringing together all of that knowledge, all of that understanding to create a sort of characterisation of the catchment, what the issues are, what the interactions are between different sectors. And as the previous talkers have mentioned, we can't solve everything everywhere all at once to start with. So the next stage is, once we've got all of this information laid out about the catchment, is then to understand a prioritisation. Where do we want to address issues first? Where are we going to see the greatest benefits from reducing obstruction in terms of improving the ecology and the river health? Or another way of looking at this may be, where do we want to avoid any unintended consequences, such as groundwater flood risking? So through the workshops, we want to work through this process of prioritising which issues and where we want to address those first. And then we can start looking at solutions. So at this stage, this will kind of capture all a kind of catchment level solution. So this could be nature-based solutions, it could be local resource options, it could be looking at changing the way that abstractors work together, and it could be interactions, say, with water recycling, so sort of discharges from that side, you know, where can we sort of move things, improve things. So the idea there is that we look at all the solutions within a catchment, and then we can then start building up portfolios. Which of these solutions do we need to fit together to tackle all the issues that we've identified through the prioritisation scale? And then these can then be brought forward to the next stage of decision making, which is through the regional plan. So in order to take all of these catchment portfolios, we also need metrics and also sort of further modelling, like discussing before, to sort of prove the benefits and the issues from each of those sort of combinations. So these catchment portfolios will then be brought forward into the regional decision making. So what I mean here is, we could potentially within one operational catchment have, say, 3 alternative combinations of options, and what sits behind each of these will be the licence reductions that are needed to support those interactions to improve sort of sustainable abstraction. And we'll be able to compare those catchment portfolios against larger, bigger strategic schemes. So this could be desalination, new reservoirs, but it can also be sort of larger multi-sector schemes, larger multi-catchment schemes, and also between sort of shared assets between water companies. So the idea is through this sort of our regional simulator model, we can compare smaller interventions at catchment level alongside the bigger strategic options to develop a combined plan that fits a regional plan, which will have this combination of strategic schemes and catchment portfolios. And this will then sort of produce a number of alternative plans that we might want to look at. And through this assessment, we can then potentially take some of this information back through to the company level or sector level to make sure that these are all still aligning and fitting together. So I think I've gone for that super fast. So if there are any questions, please do add them to the chat. But I'm just going to hand over to Teresa now, who's going to talk about the workshops.
Thanks, Jo. No, that's perfect. And I think it's how those two work together is the really important bit, isn't it? So just to kind of take that forward then, as Jo said, the workshops itself is the idea to bring all of that, as Jo said, together to feed in. And the idea is that there'll be multi-sector, multi-stakeholder for you all in the different sectors that you're here representing today, to take into account what you've been working on, to use the GIS layers, the information that we know that Tom and Andy have presented, plus all of your local information to build up that knowledge. And the idea is then we can start to kind of develop what those look like, talk through those options and ideas, and build that into your own plans as kind of business, your own understanding, but also those kind of different sector plans. And so really through these workshops, the idea is that we can have a greater awareness, you know, on the ground of what this means in your local area and your local bit of river or groundwater, how that aquifer kind of works and what the impacts we're looking like and what the models have shown the Environment Agency work. There's a real opportunity, I think, to collaborate within sectors and across sectors. And there's some great examples of this in conversations that are happening at the moment. We're going to need to be innovative to solve these solutions in the future, and the environment and our businesses need us to do that. And so there's a real opportunity here to kind of feed into the planning, feed into the evidence, and there's a few questions in the chat about how that can be locally based, and that's very much what this is all about, and to kind of, you know, make sure that we can achieve those results in the future. So in terms of the workshops, we're looking to do a number over the winter to coincide with, you know, time that works for different sectors. So through November to March, we've got a plan to kind of roll out the first set. But alongside that, we'll do kind of meetings. You know, we're welcome to come and talk about this to any of your local groups or organisations. But he has highlighted in the top half of this table where we're looking to kind of work initially, but very much the case is we want to make sure the environmental destination understanding is there across all of our areas. So as I put here, the invites are to come. It's there, they're on their way. But if you are working in any of these areas and interested to get in touch, I'd be really pleased for you to get in touch with me and we can work together. All of these will be hosted in collaboration with local organisations, and you'll see all of that as we come to share that going forward. So that's the kind of the end of the formal bit. I'd like to pick up with our speakers, if you're able to come back for a Q&A session, just for some of those ones. Thank you to our speakers and to my colleagues that have been answering the questions as we go. I think there's a couple particular ones, Tom and Andy, that I'd like to pick up and share. And then for the others, we'll make sure that the answers to your questions are circulated with the slides. So Tom, I think there's an important one that Katie and Fiona kind of raised together about how our changes that we're expecting under environmental destination will help our water environment both adapt to future changes and thrive in the future. So I don't know if you wanted just to add a comment on those.
Yeah, I mean, I probably didn't have time to go through it in the slides, so ED also includes two scenarios with higher levels of environmental protections. So essentially that's like a a smaller percentage allowable deviation from the FE. So those scenarios are the intermediate and full, so sort of increasing levels of environmental ambition, and they do include more stringent targets for chalk streams. I think that's what the question was referring to. So yeah, while that might bump up that flow target, you've still got climate change, which is kind of pushing that down. So I think to understand what that would look like in terms of, you know, an absolute flow in relation to what it is now, or the current flow target, you'd have to look at that, you know, specifically at a water body level to see what kind of wins out. You know, is it that more stringent target, or, you know, does climate change push it down even more? So yeah, and I think what I'd say is that actually in some areas, future naturalized flows are predicted to be less than the current FE. So yeah, even if in the future you have to switch all your abstractions off, you know, the flows in that situation wouldn't even meet kind of current flow targets. And that's kind of why all those other kind of ED aspects, yeah, improvement to water quality, river morphology, yeah, are really, really important to mitigate those kind of changes in the future.
Fantastic. Thanks, Tom. And Andy, just picking up on a couple of these last questions to finish us off, there's a few questions about the flow monitoring data that we've got available, how we can kind of use local data to inform the future, and how we can kind of match current, you know, abstraction license kind of changes under catchment permit reviews with our future. And I wonder if you could kind of bring all of those together in terms of how we can do that.
Yeah, I think there's the applications of the work that I was describing are both short term and long term. I think in the short term, it's building some of our sort of fundamental understanding about how these pressures individually and in combination combine to set the status of those biological communities. I think there's still a lot we don't understand, or things that we need to understand better, particularly where there's interactions between pressures. There's been some really interesting work, research commissioned by the Environment Agency, which showed that morphologically altered channels are more sensitive to abstraction than those which have a more natural morphology. So I think that's a really important lesson, that habitat restoration is really important to make sure we've got physically diverse channels with appropriate refuges to help organisms survive both droughts and moderate levels of abstraction. And there's also the interaction between water quality and flow as well, which is only going to become increasingly important under climate change as warming temperatures potentially exacerbate impacts from eutrophication, for example, as well. So we need to build that fundamental understanding. I think in the short term that will have some implications for, you know, understanding water needs at a local scale. And then as we move forward over future environmental destination cycles, I think that's also going to help with that sort of long-term regional planning piece as well. So just to manage expectations, I do think we're at the start of a journey at the moment. I think it's quite exciting. I can't wait to see what this next stage of research is going to show, but the full benefits, I think, will be realised over a longer timescale as we accumulate more and more evidence.
You, Andy, that's brilliant, and I think evidence is what we're here to do, you know, to make sure this works as we go forward, and very much informed by local where we can. Thank you, Andy. Thank you, Tom. Thank you, Joe. So just to kind of wrap up where we are for today, what comes next? If environmental destination is new to you, we've tried to distill it down on our website as to what that means and what that is, to kind of provide you the key links specifically for us in the east of England, and we'll keep to build that resource as we go forward. Al, if you'd launch the poll again, hopefully this afternoon's webinar has increased that level of environmental destination understanding as we've gone forward. Just to kind of share with you, hopefully you found them already. If you haven't, a lot of the results of what the Environment Agency have produced as a result of the information that Tom presented is available to you on your catchment level through the catchment abstraction summaries, and then on a water body level, looking at abstraction reduction risk as well. So the data, the links are here on these slides, which we'll share with you afterwards. And so it'd be great for you to be able to dig down into what that means for you. And this is the kind of areas we'll be talking at the catchment workshops. So really the next steps is understand what your local environmental destination is. Please do come along for those catchment workshops, get involved, connect your local organisation to what we're doing, feed into that evidence, and really think about continuing to incorporate water management into your business planning. I think the whole reason from the Environment Agency about environmental destination is we've got a sight to the long term whilst being minded of what's happening in the short term. And so it's kind of thinking about that water management, which I know you're all on this call, and that's what you do, but it's how we can kind of link and continue to work together. So from me, a big thank you to our speakers, to Tom, to Andy and to Joe for joining us this afternoon. Thank you to you all for coming along. As I say, the session has been recorded. If you want to go back and re-watch what Tom talked about, I think I'm going to do that many times, to talk about what Andy talked about and how that all brings together, to think about where Joe came from in terms of how we can bring that together, how you can get involved. You'll be able to do that and look at the slides. I'll take forward your basis and membership numbers, but thank you for joining us. Hopefully that's given you a good insight into where this is all coming from. And like Andy says, this is the start of the environmental destination journey, but very much building on all of your work in your local area, for your business, for your catchment going forwards. So we look forward to seeing you over the winter out and about. Please stay in touch and, talk to us as we go forward, and we can take environmental destination to that next level. Thank you very much for joining us this afternoon. We'll be in touch.